negotiable for us when we are talking about, when we are doing networking. So number system. I'm starting right now. Number system. Number system. So what's the big deal about number system? Why do we need to talk about number system? You're going to find out as we proceed that computer does not talk in our language. Computer uses binary number system. And because of that, we're going to talk about binary number system. But not just about binary number system. We're going to talk about when we talk in decimal, how does the computer see our talk or that number that we are putting, which is in decimal. So we need to know how to move from decimal to binary. This is how we put on computer. This is how the computer sees. Let me give you an example. If I go to my command prompt now, I've been to command line with you guys before, and I say IP config to check the IP address on this computer. Now look at my IP address here. I am on wireless. Look at my IP address here. My IP address is 192.168.1.249. We're going to break down this in our next class. We'll be talking about IP addressing, IP version 4. 192.168.1.249. That is human language right there. We talk in decimal. So in today's class, we want to see how does the computer see this number. And the truth is, you don't have to do anything. Computer will do what it needs to do. But for us network engineers, we need to know how the computer arrive at that destination manually. We are going to have to calculate manually. Computer will do its job, but we are going to train you how the computer arrive at that. This is more or less like somebody using calculator and somebody doing manual calculation. So we talk in decimal. Computer talks in binary. We input IP address in decimal in our computer. The computer does not see that IP address as decimal. It sees it as binary. And that's why we need to understand what this binary system is all about. So we're going to be talking about binary system. First thing first here, before we enter into calculation. So what is this binary system? How is it related to IP version 4? That is what I just explained to you here. So when you talk about binary system, that is number system, that is the computer language. How is it related to our IP version 4? I just explained that. We put IP void for address in decimal. Computer sees it in binary. So when you talk about binary system consists of ones and zeros. And that is what we call bits. Binary system consists of ones and zeros. And that is what we call bits. So when you hear talking about bits, we're just simply talking about binary system. We're talking about zeros and ones. But when you talk about decimal numbering system, of course, you know that it's from 0 to 9. All the numbers, decimal numbers in this world, you get them between 0 to 9. There is no number in this world, no decimal number in this world that cannot be gotten between 0 to 9. That's our decimal number. So our hosts, that's computer now, servers, all our equipment, they need IP addresses. But we put those addresses in decimal form. But guess what? They see the address in binary format. They see that address in binary formats. So when we put an IP address like 192.168.1.1 on a computer, this is human language. And we're going to demystify this in our next class. This is human language. This is the format of an IPv4 address. It has 4 sections. That is why you see section 1, section 2, section 3, section 4. We call it octets. Octet, the first octet, second octet, third octet, fourth octet. And of course, they are separated by dots. That is the format of an IP address. But if we put something like this on this computer, how does the computer see this? That is what we want to do into this class. Let's pick my IP address and use this as an example. So I'm going to go into the calculation now. My computer is having 192.168.1.249. 192.168.1.249. So let's pick my IP address. Thank you. Mr. Uche, you are here. Good to see you there. 249. 192.168.1.249. This is the IP address on my computer. This is in decimal format. And this is now how the computer sees this. Computer is doing its own work behind the scene. So we now want to calculate and find out how the computer sees this behind the scene. So how do we do that? We can pick the first section, which is 192, convert it to binary. Pick the second section, convert it to binary. Pick the third section, convert it to binary. And pick the last section, convert to binary. Mind you, there are calculators online. I can just go online and punch all these numbers into the calculator. I can just get binary to decimal calculator and I'll get all of this is written out. But the way the curriculum is designed, you must know how to do these things manually. That's why we are doing it manually. So let's start with the first number, which is 192. If you were told to convert 192 to binary, how will you convert 192 to binary? Don't forget, binary is in base 2. Binary is base 2 system, meaning what? With this number we're looking at now, we want to find a way to take it to base 2. How do you do that? You draw a line like this. You begin to divide this number on the right by 2, so you can put the number you're going to use to divide on the left. Mathematician in the house, I believe you know this. So what am I trying to do? I want to divide 192 by 2. You can go straight and just divide 192 by 2. Or you can start with 19, for instance. So if I divide 19 by 2, that means I will carry 19 and say divided by 2. What would that give me? That will give me 9, remainder 1. So I bring that 9 down here. I have 1 left. The remaining 2 on this side, I put it in front of that 1. The same 2 that I used to divide the 19, 12 divided by 2, that will give me 6. So I'm going to get 6 here. So that's why I say if you like, you can go straight. 192 divided by 2 will give you 96. If you don't want to go straight, you can go by with two digits. 19 divided by 2. That's what I just did in this place. 2 times 9 is 18. We have 1 left. Then you carry that 2 that is on this side and put it in front of that 1. That makes it 12. Then you now say 12 divided by 2. That gives you 6. And that is how we arrive at this 96. So this class is going to be different. I'm going to give room for questions in between because I'm dealing with calculation. In case there are issues, I don't want to have traveled far before people will now bring me back. I don't understand this. I don't understand that. So the problem I have with some muting people is some people will still not mute themselves from their side and will be having distraction coming from their side, noise coming from their side. So please, once I give room for question, try to make sure that you are muted from your side if you're not talking. If you want to talk, unmute and ask me a question. So today's class, I'm going to give room for that in between. Okay, so let me continue. So 96. So now here we have remainder 0. Meaning what? Nothing is left. Remainder 0. So I'll come down here. Sorry, guys. Remainder 0, I have remainder 0 here. Remainder 0. I'll come down here, do the same thing. You can go straight and say 2 in 96 if it's easier for you. Or you can carry the first digit here. 9 divided by 2. You know that will give you 4. You write 4 here. 2 multiplied by 4 is 8. So that means there is 1 left. That one that is left, you bring that 6 that is here in front of that one. That gives you 16. 16 divided by 2. That may give me what now? 8 again, right? No, I think, yes, 8. So that will give me 8. So I have 48. Sorry, this one is not supposed to be. It's supposed to be a remainder 0. 48 remainder 0. Then I come down again. If you can go straight, fine. 48 divided by 2. You and I know it's going to give us 24. Remainder 0. Bring 2 again here. 24 divided by 2. That will give me 12. Remainder 0. 12 divided by 2. That will give me 6. Remainder 0. 6 divided by 2. That will give me 3. Remainder 0. 3 divided by 2. That will give me 1. Guys, 3 divided by 2 is 1. remainder 1. That will give me 1, remainder 1. I'll bring down 2 again. 2 in 1, it does not go. 0, remainder 1. So what will I do? I will write the digits from under up. 1, 1, 1. Let me put it up here. 1, 1, 1, 2, 3, 4, 5, 6. Base 2. This is how the computer sees 192. You write from under, guys. 1, 1, 0, 0, 0, 0, 0, 0, because it must be 8 bits. So if you put 192 or if you see 192 on your computer is not seeing this as 192. Computer is seeing this as 1, 1, then 6 zeros in base 2. That is the language of the computer. So we are learning the conversion manually. Of course, we can do this calculator, but you must know it manually, and you will know why as we proceed. You must know that. Let me give you another example. Let's pick 168. That's the next digit there now. And find out how does the computer see this 168 in binary. How does it see it? We are moving only to binary now. Then we are going to now revert it back later. So you people can write down all these numbers, the equivalence of 192 in binary, and the next one we're going to do now. So let's pick this next number. 168 is another number, or because the IP address is 192.168. How does the computer see 168? We will do the same thing we did earlier. What we are basically trying to do is we are trying to move this into base 2. Put 2 on the left here. What it simply means, all the these numbers on the right, you are dividing it by 2. Okay? So just like I did earlier, you can start with, if you can do it straight, fine. If you are very smart, you can do it by 2 digits. I can say 2 in 16. 2 in 16 will give me 8. 2 times 8 is 16. I have only 8 left here. 8 divided by 2, or let me say 16 divided by 2 will give me 8. 8 divided by 2 will give me 4. And that's nice. So what do I have left? Nothing. So I'll say remainder 0. I'll bring another 2 here. 2 in 84, that will give me 42. If you like, you can do it 1, 1. 8 divided by 2, then 4 divided by 2. In the long run, we don't have anything left. Bring the 2 down here. 4 divided by 2, 2. 2 divided by 2, 1. Remainder 0. Then bring the 2 here again. We have 21. 21 divided by 2. That will give me 10. 2 times 10 is 20. How many I have left? Remainder 1, because I'm dealing with 21 here. Bring the 2 here again. 10 divided by 2. That will give me 5. Remainder 0. Bring 2 here again. 5 divided by 2. 2. 2 times 2 is 4. Remainder 1. Bring another 2 down here again. 2 divided by 2. 1. Remainder 0. And then the last one. 1 divided by 2. It will not go. So you say 0. Then you remainder 1. You write from under up. That is 1, 0, 1, 0, 1, 0, 0, 0. So that is 168. 1, 0, 1, 0, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Base 2. This is how the computer sees 168. One more example. See how we're moving, doing this calculation manually. But don't worry, computer will do this for you. But you'll see why we're doing this later on. Because we're going to get to a place where we need to. This is not clean enough. Just a minute, guys. It's like this is freezing. Okay, we're good now. Let's pick another one, which is 1. The next number there is 1. How does computer see 1? Same thing we did, guys. 2 in 1. 0. Remainder 1. 2 in 0, 0, remainder 0. 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 Why? Because this digit must be 8. So I'll keep on doing until I have 8. 2 in 0, 0, remainder 0. 2 in 0, 0, remainder 0. So in the long run, my answer will be 1, 2, 3, 4, 5, 6, 7, 8. That's how computer sees 1. This is equivalent to 1. And of course, I'll pick the last one, guys. Base 2. Don't always forget to write your base 2. So I'm going to see. Let's go to the last one. Yes, thank you, Mr. Uchi. I like you're giving me right on. And it is helping the anointing to move. Thank you, guys. So the last number here, which is 249. How does the computer see 249? Don't forget we're analyzing my IP address. Thank you, Mr. Bello. Same thing we did. Oh yeah, so this one again. I have 249. I want to convert it to binary. You can start with the first 2 digits. 24 divided by 2 will give you 12. 9 divided by 2 will give you 4. Remainder 1, because 2 times 4 is 8. Then you bring down your 2 down here again. 12 divided by 2, it gives you 6. 4 divided by 2, it gives you 2. Remainder 0. Bring another 2 here. 62, you can go straight. Divided by, if you like, 6 divided by 2 will give you 3. 2 divided by 2 will give you 1. Remainder 0. Bring another 2 here. 31 divided by 2, you can go straight. That will give me 15. 15 times 2 is 30. Our remainder 1. Then bring another 2 here. 15 divided by 2, that will give me 7. 2 times 7 is 14. Remainder 1. Then bring another 2 here. 7 divided by 2, 3. 3 times 2 is 6. Remainder 1. Then bring another 2 here. 3 divided by 2, 1. Remainder 1. Bring another 2 here. 1 divided by 2, 0. Remainder 1. You write from under up. That will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, 0, 1. Base 2. This is how the computer says 249. So I need you guys to write out all the binary numbers and their equivalents, because we're going to go back from binary to decimal. We're going to go back from binary to decimal. So let me see if anybody has question. I don't want to open. I'll meet you guys. Just drop a message in the chat if you have a question. If you are all clear, let me see your thumbs up, and we can move from the other side. We're all clear. Let me see your thumbs up, guys. If anybody have a question, drop it in the chat. Let me hear your question. Because if I unmute you guys now, that may cause trouble for us. Thank you. I'm seeing all your thumbs ups. Mr. Ayodeji, can you drop your question in the chat? That is easier and better for me. Good. So if we don't have problem, then we're going to go the other way and move from binary to decimal. Yes. Why 8 digits for 1? Good question. Why 8 digits for 1? You know that all the numbers we've been dealing with are 8 digits. Every number in an octet, every decimal number in an octet should give you 8 digits. Why is it 8 digits? We're dealing with 8 bits. Why are we dealing with 8 bits? 8 bits is equal to a byte. It must be 8 digits, and it must be 8 bits. Whether you have 8 zeros, or you have a combination of zeros and ones, or 8 ones, as long as you are dealing with IP address, in an octet is always 8 bits. Let me go back to my slide and show you and explain something to you. In an octet, everything you have in an octet is 8 bits. So this first octet you are looking at here right now, this first octet 192, when you convert it to binary, it must give you 8 bits. Why is it 8 bits? Computer talks using bytes, bits and bytes. And for you to have bytes, 8 bits is equivalent to a byte. There's nothing like 7 bits, 6 bits, 4 bits. It will not work out like that because that is not the way computer talks. It talks in bits and bytes, and 8 bits is equivalent to a byte. So each of this section you are looking at in an IP address is equivalent to 8 bits. Even if I have the 0 in an octet, you must give me 8 bits. Yeah, somebody was asking a question. Why can't you divide directly? Yes, you can divide directly. I'm just trying to make it simple and easier for people that may run into trouble. Decimal is in base 10, that one day. I just didn't mention that one. All these 192.168.1.249, they are decimal language, and that's base 10. So it must be 8 digits, or let me say 8 bits. Is it a must? Dennis, it's a must. You must arrive at 8 bits. That's computer language. That's how IP addresses are structured. 8 bits in an octet, 8 bits in a section. Benga, I hope I'm clear. Dennis, I hope I'm clear. So if there's no other question, guys, we'll go and move from binary to decimal. So let's write all those binary numbers and their equivalents and let's write them out. So I'm going to write them out for my own head here. You can also write them out so that you can compare when we are done. So write out what we got for 1 and 2 in binary. 1 1 168. 1. Then 249. So Adolf is saying, oh, now it makes that physical layer PDU is bit. Yes, you are correct. When we talk about bits, this is what computers does. And it's not only this number that is converted to bits. Every data, everything that is traveling across the wire is converted to bits. Everything. Everything. So now I want to go the other way. So when I say I'm going the other way, I'm going to carry the first number that we got, which is 192. I'm going to clear this now. And let's now see. If I gave you this number now, 1 1 1 2 3 4 5 6. This is in base 2. And I told you, convert this to decimal for me. You and I know that this is 192. We did our calculation. We got here from 192. Now we want to go back. So this is binary. But it's not our language. It's computer language. So we want to convert back to decimal. How do we convert to decimal? So you are simply trying to convert to base 10. You are trying to go from base 2 to base 10. And how do you go from base 2 to base 10? You put these things in power of base 2 and expand them. You put them in power and expand them. What do I mean by that? This base 2 that you are looking at here, let me carry the first binary digits here. How do I expand this? It has to come in the power. The first power we're going to deal with is raised to power 0, followed by 1, followed by 2, followed by 3, followed by 4, followed by 5, followed by 6, followed by 7. How do we make sense of this? I'm going to deal with the first bit here. I'm going to say 0 multiplied by 2 raised to power 0 because I'm dealing with base 2. The first power I'm dealing with is power of 0. This is the first part here. Plus the next one called 0 multiplied by 2 raised to power 1. You see the power here. I'll put it in a circle. Plus 0 multiplied by 2 raised to power 2 as these two here. I move to another place. plus 0 multiplied by 2 raised to power 3. Dealing with this one here. Plus 0 multiplied by 2 raised to power 4. Is dealing with this one here. Then I can continue on the other side because of space. Plus 0 multiplied by 2 raised to power 5. I've done 4. I'm here now because I'm dealing with 0 here. 0 multiplied by 2 raised to power 5. But guys, watch out. The next digit here is 1. That will be 1 multiplied by 2 raised to power, see the power here, 6. It's going to be calculated separately. Plus 1 multiplied by 2 raised to power 7. And we're done. Expanding these things. So this is where some people they run into trouble. 2 raised to power 0 is 1. So sometimes people get this thing mixed up. They say 2 raised to power 0 is 0. No. When you are doing power, 2 raised to power 0 is 1. So that would be 0 multiplied by 1. And guess what? Anything multiplied by 0 is going to give you 0. So in this box right now, we got 0. What about the next box? 2 raised to power 1 is 2. Multiplied by 0, we got 0. The next box, 2 raised to power 2 is 4. Multiplied by 0, we got 0. The next one, 2 raised to power 3 is 8. That means 2 times 2 times 2. 2 in 3 places. Not 2 raised to power, not 2 multiplied by 3. 2 multiplied by 2, multiplied by 2. That is 2 in 3 different places. That will give us 8. 8 multiplied by 0 is 0. Then this other one too, 2 raised to power 4 is 16. That is 2 times 2 times 2 in 4 places. Then 16 multiplied by 0 is 0. When you come to this place and come, 2 raised to power 5, that will give you 32. Multiplied by 0 is 0. And guys, you have to be careful here. Because this is 1. It's not 0. 2 raised to power 6. Meaning what? 2 times 2 times 2 times 2 times 2. That is 1, 2, 3, 4, 5, 6. 2 in 6 places. 2 multiplied by 2, 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. 16 multiplied by 2, 32. 32 multiplied by 2, 64. 64 multiplied by 1. This box will give me 64. What about the last box here? 2 raised to power by 7. 2 raised to power of 7. 2 times 2 times 2 times 2 times 2 times 2 times 1, 2, 3, 4, 5, 6, 7. This one, when you do your calculation, will give you 128. So this second box gave us 128. Since all these guys are 0, we have no business with them. We only have business with the one that is giving us real number. 128 plus 64. That will give me 4 plus 8, 12. 6 plus 2, 8 plus 1, 9. That will give me 192. Did we arrive at the where we came from? So you must learn to move from binary to decimal. Thank you, guys. And also vice versa. And I'm going to show you the easier way, the easiest way. I'm just going the hard way now. I'm going the hard way. We're going to see the simple one. Thank you, guys. So let's pick another number. We deal with 168 also. Let's pick 168. 10 101 000. That is base 2. You were told to convert this to decimal. Same thing we did. Expand it. First of all, you can put the power so you don't get confused. This first one will go to the power of 0. The next one will go to the power of 1. The next one will go to 2. The next one will go to 3. The next one will go to 4. The next one will go to 5. The next one will go to 6. The next one will go to 7. If you don't want to stress yourself, first of all, cancel all those one that has zeros. You know they will still amount to 0. Deal with the one that has the 1, 1, 1. So if I pick this one right now, that means I'm going to have 1 multiplied by 2 raised to the power 3. I'm simplifying it for you now. Pick the next one where they here. 1 multiplied by 2 raised to the power 5. Pick the last one here. 1 multiplied by 2 raised to the power 7. So expand it. 2 raised to the power 3 is 8. 8 times 1 gives you 8. 2 raised to the power 5 is 32. 32 multiplied by 1 gives me 32. The last one, 2 raised to the power 7 is 128. 2 times 2 times 2 times 2 is 128. 128 multiplied by 1, that will give me 128. Then add all of these ones together. What will that give us? 128 plus 32 plus 8. That should give me, the first one will give me 18. So I have 8 here. 2 plus 3 is 5. My plus 1 is 6. Yes, then bring the 1 down. Then I get my 128. Anywhere you have zeros, you can ignore them because you know you are still going to arrive at 0. Anything multiplied by 0 is 0. Take care of all the ones that have the 1. I'll give you a short form now already. I arrive at my 168. So when you want to expand, once you put the power, you can only pick the ones that have 1s alone. Expand them. Forget about the ones that have 0. Just don't mix up the power. If you mix up the power, it will not be correct. So now this is equivalent to our 168. We move from binary to decimal. Now we are moving from decimal back to binary, guys. So take note of that. Thank you, guys. So let's pick 1. Because that one looks confusing to people. 1, 0, 0, 0, 0. That is 4. 1, 2, 3, then 1. This guy is in base 2. Put the power. 0, 1, 2, 3, 4, 5, 6, 7. You know all these guys will end up being 0. So let's take care of this one alone. 1 multiplied by 2 raised to the power 0. Anything raised to the power 0 is 1. 1 multiplied by 1 is 1. It will arrive at our 1 back. We are expanding this one. 1 multiplied by 2. 2 is the base. Raised to the power 0. The power is 0. So 2 raised to the power 0 is 1. 1 multiplied by 1 is 1. This is our decimal format. We are back to 1. So we are seeing the number as this in base 10. Computer is seeing it as this in base 2. It makes no difference. We just need to know what's going on behind this thing. Is this one clear? I've lost you guys. Thumbs up if I'm communicating. Yeah, good. We have one more left. Then I'll give room for question again in case we have question. Thank you, Mr. Samuel. I've done this again and again and again, and I'm always cracking my brain on which the better way to deliver this. And we always try to do. You will see one more thing we're going to do before we finish. So let's do the last one. We have 1, 2, 3, 4, 5, 0, 0, 1. It's in base 2. That was our last number. You were given this. Thank you. And you were told to convert it to decimal. Not a problem. Same thing we did before. So 0, 1, 2, 3, 4, 5, 6, 7. You know, these ones will amount to nothing. So forget about them. Let's pick the first one. 1 multiplied by 2 raised to the power 0. We know, you and I know that this will give us 1. Because 2 raised to the power 0 is 1. 1 multiplied by 1 is 1. Let's pick the next one here. 1 multiplied by 2 raised to the power 3. 2 raised to the power 3 is 8. 8 multiplied by 1, we're going to get 8. The next one, 1 multiplied by 2 raised to the power 4. 2 raised to the power 4 is 16. 16 multiplied by 1 is 16. The next one, 1 multiplied by 2 raised to the power 5. 2 raised to the power 5 is 32. 32 multiplied by 1 is 32. The next one, 1 multiplied by 2 raised to the power 6. 2 raised to the power 6 is 64. 64 multiplied by 1, it was 64. And then the last one is 1 multiplied by 2 raised to the power 7, which is 128. 128 multiplied by 1 will still be 1. If you add up all of this now, somebody should add it up from that side here. You will arrive at 129. 249. That is 128 plus 64 plus 32 plus 16 plus 8 plus 1. Can you guys do the calculation? You are going to arrive at 249. And that was what we did. We moved from 249 decimal format to binary, and then we are moving back to decimal. If you do your addition, you're going to get the same thing. No. 32-bit and 64-bit is a different thing entirely. That is under Computer A+, IT Essential. Yeah. So this is how you move vice versa. But I want to show you one more thing before I give room for question, which I have taught my students over the years to cram, so you don't have to be doing all of this long calculation. Let's assume I gave you 1, 2, 3, 4, 5, 6, 7, 8 base 2 to convert to decimal. This is going to be raised to power 0, raised to power 1, raised to power 2, raised to power 3, raised to power 4, raised to power 5, raised to power 6, raised to power 7. Do you really need to do any calculation? You don't need to crack your brain. You know why? We, from our experience over the years in teaching, we know that the first one here will be 128. The next one will be 64. The next one will be 32. The next one will be 16. The next one will be 8. The next one will be 4. The next one will be 2. The next one will be 1. So you can cram this in now. 128, 64, 32, 16, 8, 4, 2, 1. So how do you make sense of this? If I now give you a number from nowhere and I say 100, 100, that is 1, 2, 3, 4, 5, 1, 1. Convert this to binary. All you need to know is the power. You know that this one is 0, 1, 2, 3, 4, 5, 6, 7. So from here now, you know that the second one here will give you 2. The one with 0, you don't have any business with them. What about the first one here? 1 multiplied by 2 raised to power 0. You know that one will give you 1. Where you have 1, 1, you know, you just take note of the positioning. What about the one with 4 here? You know that anything 4, 1, 2, 3, 4. The one with positioning of 4 will give you 16. What about the one with position of 7 will give you 1, 3? You just write out the number. Or the one under 7 is 128 plus 16 plus 2 plus 1. You just write them and then add them up. So anytime my students are doing calculation, I just tell them, know the positioning. Know that this one is under the position 0, position 1, position 2, position 3, position 4, position 5, position 6, position 7. As long as you have 1 there, just pick the number from above. Anywhere you have 1, know the position, pick the number. You don't need, if you do the calculation, you're still going to arrive at that. Of course, if you add up this one that is in this place right now, guys, it's going to give you 255. So if you know this, you understand this, it will help you when we get to something called subnetting. This is key. This thing we are doing right now will really help you when it comes to subnetting. So you need to understand this concept and understand it very well. I'll give room for questions, guys. If you have question, drop your question. Thank you. So before we go to the last part,